Hi everyone, it's Blake with FicheBait. In this video, I'm going to share how you can keep your Laserfiche databases running efficiently using Ola Hallengren's SQL Server maintenance solution. So if you've ever wanted to get the best performance from your Laserfiche system, then keep watching. The first thing that you're probably wondering is, why would I want to implement this solution and what is it? The Ola Hallengren SQL Server maintenance solution is a set of scripts for running backups, integrity checks, index and statistics maintenance for your Microsoft SQL Server. You can read all about it and the different options that the solution provides on their website, such as SQL Server Smart Backup in multiple files, incremental statistics, online resumable index rebuilds, and a lot more. If you aren't familiar with all this different SQL Server terminology, you might be wondering what all of that means. Backups are pretty self-explanatory. They're going to take backups of your databases, so if you ever have a problem, you can easily restore it and get everything back. Integrity checks, they basically just help ensure the consistency of the database by looking for different errors or corruption that might exist. Index and statistics helps with SQL Server performance. SQL Server uses indexes and statistics to create what's called a query plan to execute a piece of SQL and T-SQL that is passed to it, which is what you use to create your queries. And then SQL Server uses statistics to determine which execution plan it should use when a query is compiled and executed. So having the latest statistics helps improve the database's performance. I like to think of it kind of back in the day when we had spinning hard disks. When you would defragment your hard disk, right, we would get better performance out of it because it would update the indexes, it would put the information together, and that's kind of what some of those parts of this solution do for your databases. So for this video, I'm going to keep things pretty simple. We're just going to walk through how to implement the SQL Server maintenance solution in a standard Microsoft SQL Server environment. So we're not going to do multi-server, we're not going to do multi-backup files, anything like that. We're just going to keep it pretty mellow. We'll download the solution, we'll edit the script, execute the script, and then verify that the scripts ran correctly. And once we do that, we'll then schedule the job so they can continue to run on their own in the future. One of the first things that we need to look at before we run this solution is if our SQL Server version is supported. We can find that in a couple different ways. You can see here on their website up at the very top, it tells us the different SQL Server editions that are supported. We can also go to frequently asked questions. And if we scroll down a little bit, we have this section right here that tells us the versions. So as of this video, SQL Server 2008, 2008 R2, 2012, 2014, 2016, 2017, 2019, 2022, Azure SQL databases, and Azure SQL Managed Instance are all supported for this version of the solution. If for some reason you are using SQL Server 2005, you shouldn't be because it's no longer supported. There are a set of scripts that you can use there as well. The solution is also supported on all editions of SQL Server. So if you have Enterprise versus Standard, anything like that, it is supported on all of them. And then the last thing here that I would look at is the compatibility level required on the databases. So the database where you're going to create the objects for this solution has to be in compatibility level 90 or higher. All other databases that you'll have on your SQL Server can be at any compatibility level that you choose. But the one that you're going to install the objects on, which is usually the master, must be at a level 90 or higher. So some of the other things that we can look at on the website, we can see that we have individual pages for the backup solutions. We can see there's different parameters and things that we can use as part of this. We'll talk a little bit more about that here in just a few seconds. We have our integrity check, and it has its own set of parameters as well. And then our index and statistics maintenance. You can download each piece of this solution individually. So if you just want the backup, right, you're able to download the objects as separate scripts on the downloads page. Or you can download the entire solution all together, which is what we're going to do. So you can do that from the downloads page here, or you can do it from the various other pages that are on their website. I've already downloaded it. So I'm just going to open that up in SQL Management Studio. You can open it in a text editor if you want, or even Visual Studio, anything that's able to read the context of the file. Starting at line 22 is where we want to start editing. And you'll notice, if you look at the scroll bar, there are a lot of lines of script in here. So there's over 9,100 lines. So when they put this together, they did a really good job. It's very powerful. They put a lot of time and effort into this solution to make it easier for the rest of us. But we're going to start here at line 22 on this script. And line 22 is where we can specify the database where the objects for this solution will be created. By default, it's set to master. If you wanted to do this or install or create these objects on a different database, you would simply come over here and you would change the master value to the database where you wanted that to be. So we're going to leave ours set to master. And then the next one that we're going to come down to is line 27. This is where, if we're going to use the backup functionality of this solution, this is where we will put the path for where the backup should be saved. So I have actually created a path already on my C drive. This is just a demo environment. So I just have it on the C drive in a folder called SQL Backup. More than likely you'd have like a separate hard drive than on your SQL server that you would back things up to and save everything there. The next line that we're going to edit is line 28. And line 28 is the number of hours that we want to keep the backup files for. So as an example, if you wanted to keep your backups for a week, we would set this to the value of 168. If you leave this value set to null, then no backup files will ever be deleted when the job runs. And not setting that can, as you can guess, cause some disk space issues later on because nothing will ever get deleted. So we are going to change ours to 1 since, again, this is a demo environment. We don't care really how long we keep them. So I'm just going to change that to 1 and we'll call it good. And with that, those are all the changes that we need in order to execute this script. So I'm going to go ahead and execute it. You will notice that it doesn't take long to execute. It just took a few seconds. For example, actually 1 second, we can see down in the right-hand corner. But it doesn't take very long to create the different objects and everything that this solution needs. So with the script executed successfully, let's take a look and see what it did. To do that, we're first going to go to the master database. We will expand master, go to programmability, and stored procedures. Here we can see that there's 4 stored procedures that were created: command execute, database backup, database integrity check, and index optimize. Next, if we come down and we look at the SQL Server agent, and then in jobs, we'll also see different jobs that were created for us. The first set, or the first job in here, is the command log cleanup. This job will run to clean up the different logs and things that are used for this solution. So if you don't run this, you don't schedule it to run, it can cause some issues because it will get quite large and can cause some space issues for you. The next one that we have, or the next few that we have here, are database backups. So the first one is a full backup of the system databases. And then we have a differential of the user databases, a full of the user databases, and then a backup of the user databases log files. The next two are the database integrity checks, our system databases and user databases. And then we have one for index optimize. It's usually not best practice to run index optimize on your system databases. And so that's why we don't have a job specifically for those. For those of you that don't know what the difference between system databases are and user databases, if we scroll back up to the top here, you see the folder here that we have as system databases. These ones are created with SQL Server, and those are known as your system databases. Your normal application databases and things like that, those are going to be your user databases. So that's what the difference is between those. You'll also notice a few other jobs down below. A lot of these are cleanup type jobs. So output file cleanup, we're deleting backup history, job history, and purge history. So that's just trying to keep things nice and tidy for our system. So again, we don't get too large of a database as time goes on. Each one of these SQL Server agent jobs utilizes our stored procedures that we just talked about up above. If we right click on one of these and go to properties and go to steps, we can see this one has a step. If we select that and click on edit, it will show us the command that is going to be used in order to execute this particular job. And you'll see here that for index optimize databases, it's user databases, log to table yes, update statistics, all of that. If we go back to the website, and in this case, if we go to the index and statistics, we can see these different parameters. So if we look at SQL again, index optimize, you can see where these parameters are coming into play on some of these. So if you want to learn more about what your different options are for each of the jobs, be sure to browse the website and read up on it. They can give you some more information as to what might be best for your implementation of SQL Server and the databases that you have. Everyone's environment is a little bit different, so while it's great to follow along with what I'm showing you, it's usually best to read through and get a good understanding so you know what to do for your system. Another thing you can do is if you go on YouTube or do a search on the internet, there are a lot of industry experts that use this solution, and you can go and read up or listen to what their suggestions are for different types of databases, and then you can add those into your backup jobs, into your indexes, everything else. If we come back to SQL Server, this was just the one for the index optimized for the user databases. Each one of these jobs, if you were to open it up and go to the steps, you're going to see the same type of thing. So you can customize each one with its own set of parameters in order to customize it for your solution. I'm going to copy the script that's being used for the index optimize. I'm just going to open a new query window here, and we'll paste that in there. Something else that you're able to do if you want to get an idea of what this is going to do when it executes is we can actually add a parameter in here called execute. And by default, execute is set to Y, which means it will execute and actually run everything. If you just want to see what it's going to do, you can actually set execute to N. And when we execute it, you'll only get the script output, so you can validate the commands without executing anything. And I always forget this. I forget to add my commas after each one. It also helps if you add an equal sign. So once we execute that, it can take a few seconds. It may take longer on a production system. But here we can see the output of what is going to happen when we actually execute this job. So I can give you a lot of details. You could read up on that on their website and get a good understanding of what all your different options are again. Now that we've kind of seen and have a basic understanding of what's happening with the stored procedures and the jobs, let's go back to our SQL Server agent jobs and let's verify that these will execute without any errors. So since I already have the index optimize up, I'm just going to delete the execute and we will hit execute. And again, it may take a few seconds, so it will probably take longer on your production system. But here we can see that we actually executed, everything was done, so we know that that's going to work. And then we can also go into our other jobs here. So I'll go into our system databases backup. We will grab the step for that as well. I'm just going to paste it in here. We'll hit execute. Again, we can see it's taken a few seconds and it's completed. For the backup jobs, we can then also come in and verify that the backup ran correctly. So we can actually see we have our system databases backed up here and everything was done correctly. So what you'll want to do is you'll want to walk through each one of these jobs that you plan on using and verify that everything is going to execute correctly. By doing that, we're making sure that when these are scheduled to run on their own, that they'll actually work correctly. It's a mess when you find out later on after it's been running for a few weeks that, hey, your backups haven't actually been working the way that they should. So verify it now, take the time and effort to put into it to get it set up correctly, and then you'll feel a lot better when you sleep at night because of that. So now that we've made sure that our jobs will execute, what we need to do next is actually schedule them to run on their own. But the big question becomes, when should we schedule these jobs to run? And that really depends on several different factors, such as your maintenance window. How much time do you have to be able to run backups and index optimize, database integrity checks, right, during your off hours? What are the sizes of your database? And how much data can you afford to lose as an organization? Right, the longer in between your backups, like your differentials, the more data you'll lose and have to recover or re-enter into the system. So you'll have to think about all those things when you're coming up with a decision of what kind of backup schedule or maintenance schedules for your different jobs here. And every organization is different. Some organizations may also have a different backup solution for SQL Server. So if you do, you may not actually use these backup jobs at all, which is completely okay. So make sure you check with your IT department, get an understanding of how all that is working within your organization. Now, the website does have some suggestions of how often you should run your backups, how often you should execute these jobs. So if you go to the frequently asked questions, there's a section down here called scheduling, and it said, how should I schedule the jobs? So for user databases, full backups 1 day per week, differential backups all other days of the week, transaction log backup every hour, integrity check 1 day per week, and index maintenance 1 day per week. For system databases, full backup every day, and integrity check 1 day per week. And then you have your cleanup jobs, and it recommends 1 day per week for each one of those as well. And again, this all goes back to what can your organization afford to lose, especially with your backups. Is one differential backup a day going to work if you have to recover from your system being down? So you may actually set up your differentials multiple times a day in order to not have to recover as much data if it were lost. So now that we have an understanding of what kind of schedule we might want, let's go back to SQL Server Management Studio. We'll go to our jobs here on the left-hand side. I'll go back into the system databases full database backup job. We'll go to properties. And we saw steps before, that's where we were previously. We're going to go now to schedules. And down at the bottom here, we have a new button. We'll go ahead and click that. And here we can set the schedule that we want this job to run on. So again, make sure that you have your plan of how often these jobs are going to run, which ones will run when, and that's what you'll use for your template here. So you can simply come in and give your job a name. So if we want it to run Sundays, you can name it whatever you want. If your organization has a naming scheme that you want to use, feel free to use that. You'll tell it how often. So you have different options here. And then also your time. So what time of day do you want this to run? I definitely recommend not scheduling all of your jobs to run at the same time. I recommend staggering them as much as possible, because the more jobs you have running at the same time, especially in a production environment, the more resources are going to be used, and these different backup jobs will be fighting for those resources in order to complete. So if you can stagger them out, you'll usually have a better success rate because they won't be competing against each other. So once you've gone through and you've set your schedule, you can click OK. And you can now see that you have a schedule listed there for this job. If this were something like a differential, where you want to schedule multiple times during the day, it's going to be this same type of window. You can then click New again and create another schedule for this job. So you can do that as much as possible, or as much as you need to, based on the needs of your organization. There hasn't been an update for this script or for this solution for around 2 years now, but when an update is released, you might want to figure out which version you're currently on. You can do this in a couple of different ways. You can come up to the stored procedures, for example, and you can click Modify. And if we scroll down, we can see the date or the version line for the stored procedure that we currently have. The other thing that you're able to do is if you go to the website on the frequently asked questions page and scroll down a little from the top, there's also a script that you can run. So if we open that script, we can just hit execute, and it will tell us basically the versions of each of the objects that we have implemented for our solution. So that will give you a good idea of where you're at. If there is a new version, you can compare it against it that way. I highly recommend that you review the documentation for the solution on the website before trying to use any of it. Make sure that you understand what the settings are, especially the ones that you should be using for your environment. Not using the correct settings can really make things worse in SQL Server instead of making them better. So again, make sure you review all of that and get an understanding of what you're doing before you start executing some of these. For those of you that are wondering, do I need all those other parameters and things like that? Most of the time, you can use the defaults that are included with the original script. That's usually, as long as you don't go crazy with your scheduling and stuff, that's usually good enough for most implementations. At least better than what you already have if you're not running any maintenance at all. So that's a good place to start if you just want to get started. And then you can kind of go from there and build on the solution for your implementation. So there you go. I hope this video has shown you how you can utilize Ola's SQL Server maintenance solution to help your Laserfiche databases perform more efficiently. If you have implemented this solution at your organization before and you want to share some tips with the rest of the community, or if you have any questions, be sure to leave a comment below. And if you like this video, be sure to give it a thumbs up, subscribe, and turn on the notification bell to get the latest Laserfiche tips, tutorials, and how-tos. And until next time, keep fishing.